Thanks, DJ. Thanks for inviting me, DJ. This is great, and great to see a lot of familiar faces, lots of VMware folks as well. As DJ said, my name is Pradeep. I'm a principal engineer at Cisco. Kiran should be here somewhere. Oh, here. Kiran and I, we started ContainerX, so we got acquired 3 months ago. It's been really hectic, but lots of good stuff. So what I'm going to talk today is talk about stateful apps with microservices. So at ContainerX, we built a container management system a la vSphere for containers. So for that, we actually built it as a collection of microservices. And as you can imagine, a container management system needs to have state. It needs to track containers, VMs, and more, right? So what I'm going to do is talk about some of the patterns, some other learnings. And in fact, Rian and Madhuri are going to follow up with some of the details of like upgrade and a few other things about microservices. All right. So you all know this. Microservices are all the rage. Only from 2014, actually. So this is the new buzzword, right? So there is a lot of stuff going on, and there are some good things and bad things. So one of the things I want to do in this talk is to like get to the first principles and understand why we are doing this and how to do that, and think about a framework in which we can talk about some of the deployment issues, scale, and so on. Right? So what are microservices? Any takers? What is a microservice? Come on, guys. This is a microservices meetup. I thought everyone knew. All right. Awesome. That's good. That's a good start. Let's make app to be broken into smaller pieces so that they're more manageable. That's a good start. Sure, of course. Anything else for microservices? Go ahead. Sure. Yeah. So microservices, we can take them as Lego blocks and combine them, hopefully, right? I don't know if they all fit together very nicely. We'll see. So I'm going to take this as the definition for today's talk. I know microservices mean different things to different people, and there's been a lot of talk about it. But for this talk, I'm going to define it as independent deployable unit. And we'll talk about more about that, what that means. So what that means is that we should be able to deploy the microservice on its own, right? Again, there are, some corner cases as to what that means. It should be able to scale on its own. We should be able to scale it independent of other services it is talking to, or other services that are talking to that specific service. And finally, it should be upgradable on its own. So this is one key thing, and Rian actually will go into some of the details of that as well. And for many people, this independent deployable unit is a container, right? And thanks to Docker, last 2-3 years, we've seen the emergence of containers, and Docker made it very easy to use, right? So now people see it as a way of like deploying microservices in containers, one microservice per one container, right? But let's dig into the details. Right? So you've all seen the monolith apps and the monolith database that stores the state for that monolith app. But it's time to say #slay the monolith. So I got this from the tweet sent out for this meetup. So I had to add it. But let's see what does that mean, right? So we can convert this into a bunch of microservices, and they all talk to each other in complex ways. And maybe more importantly, each one has its own state. So if you see, there is a database attached to each service. Do you guys see any problem in this? What is that? Too much dependencies, that's one. What about the state? Right now, yeah, go ahead, sorry. Yeah, exactly. Yeah, so that's the very important thing, that the state is distributed now, and they are in different places, managed by different services. The other part is we have now 4 databases. Just to be clear, when I say database, it doesn't mean just RDBMS. It could be a NoSQL database. It could be like a console etcd kind of distributed state management system, key value store, if you like. Right? So the problem is, how do you manage the state? Now that Slay the Monolith doesn't look as appealing, right? Earlier, it was easier to just take like one database, one app, put it in one place, and sure, it takes a lot of work to deploy, scale, upgrade, but now I have like 4 pieces, or maybe 8, or the matrix of 4 by 4, right? So that's getting complicated. So how do we solve this? So I keep hearing about let's make everything stateless. Right? How many of you know about 12-factor apps? I'm sure pretty much everyone heard of it, right? So 12-factor apps, I like to call them Heroku apps. So Heroku invented them to sell Heroku, right? So 12-factor apps, there are like some good principles there, but not all apps fit into that pattern, right? We developers want flexibility in terms of how to write the apps, tools to use, and so on. So how do we handle this problem, right? We want to make maybe most of the services stateless, but what is the fundamental question that we are answering, right? That question is how to manage the state. So before we go into like answering that, let's take a simple example. So this is Nginx. As you guys know, it can be used as a web server, maybe even like a load balancer. Docker run -d Nginx. Most of you have seen this command that just runs the container. Is this stateless? Yes? No? Yes? No, I hear no, yes. Why no? Okay. Trick question, right? It could be both. So as it is, how do I access this? There's no way to access it, right? And the host, we haven't exposed any ports. What is it serving? Does it have any files that is serving? Maybe the state, right? Nothing. So this stateless app is pretty much useless, right? Because it's not doing anything. It's just running a process, not serving any files. So it becomes a stateful app or a useful app when we do these things, right? Many of you are familiar with the Docker command line syntax. What we are doing here is that the first one, exposing the port of this container to the host port of 80. So I call it deployment state. The second line is saying that, hey, take a configuration file and give it to the container so that the container can initialize itself. When Nginx starts, it can read from there. Maybe number of worker threads, where the logging should go, and so on. Finally, the service state itself, right? The files it is serving. Now we have something useful here, right? So even the simplest of the things, like if you search for web server stateless, there are like, I don't know, hundreds or thousands of results, right? Is web server really stateless? It depends on how you look at it, right? So there is state in terms of how you deploy it, how you configure it, what you serve from it, maybe even more complicated, like maybe there is a F5 load balancer in front of it, and we need to configure that too. We could argue that that's part of the state for this app. So we'll get to the service state in a minute, but let's see how we can handle deployment and configuration state, right? So one way to do it is what we saw in the previous example, that you you put this data in persistent volumes, use an orchestrator like Kubernetes or Docker Swarm, or the Docker itself, like in 113+, to manage that, right? So until recently, this was very difficult to do. Adding persistent volumes to your containers, lifecycle management of that, and so on was very difficult. So Kubernetes introduced persistent volumes, and you should use it for managing the state. Yeah, go ahead. Yeah. Yeah. Mm-hmm. Yeah, it's a end-to-end app, right? So I like to think of it as end-to-end application deployment. So you got a binary, and you being the operator, you need to deploy the Nginx web server in your environment and use it for something, right? You just bought the product, let's say. That's what I mean. So end-to-end deployment it doesn't mean I just run the process, right? I configure it, I put some files in it, I connect my FI load balancer, maybe configure networking, and so on, right? So all that is part of the application management. All that is part of like the overall infrastructure management. If we just take the process, yes, it's stateless, right? There is nothing, I mean, it just runs. But we need configuration to configure it. So that's the point I wanted to make actually, right? So if you look at the app or the process itself, maybe it doesn't, I mean, you can restart it any number of times you like. Then is it stateless? Not necessarily, right? The process itself can restart, but the configuration, maybe we have to change it over time. Then it has state. Yeah, so yeah, that's a very good question. Actually, I wanted to add that here as well. But again, app means different things to different people, right? So to me, it's a collection of microservices providing a service, right? It might be internal service, like in this case, web server, or an external, like a software as a service that you are providing to other people. So that whole collection of that whole thing is an application for me. So if I take the example of Container right, or vSphere, many of you are familiar with, right? So if I take vCenter, that's a full app, but vCenter it's a monster, right? I don't know how many, Nilima has worked on it, and many people here worked on it. I don't know how many processes today it has in that VM, and more, right? It has multi-VM configuration as well. But all that combined is one app for me, because all I do is I go to the vCenter UI and use it. Right? I'm sorry, say that again. Monolith. Yeah, I mean, you want the full functionality, right? Exactly, yeah. So because as a service, sure, I mean, you can take one service and say, hey, this is giving web service. Is it stateless? Just the process itself is stateless. So let's move on. We'll get back to the more details as well. So Kubernetes, I didn't want to get into details of how to set up persistent volumes. I didn't mean to like explain all these things. So I refer you guys to this guide to go through the details of how to set it up. But let's move on with more details of like state, right? So I want to take the real world example, in this case, the Container management server itself. So Container management server, again, think of it like vSphere, and it's a collection of microservices, and I picked only the two important services and one API call. So it has two services called CORK and SDDC. CORK stands for Container Orchestration. You don't need to understand what that means, just assume that it's a service. And SDDC, Software Defined Data Center for Containers. So SDDC is a nice service that actually provides an API where you can say, hey, give me a cluster on AWS with 4 VMs, and then it will figure out how to call AWS API and takes care of that. Similarly, you can do it for vCenter and so on. All that is nice, right? Now, both of these services have certain state. So if you look at SDDC, it stores the credentials for AWS, for example. Again, I'm simplifying a little bit for illustration, not to be taken literally. And for CORK, let's say we are storing all the user information, like the Container management server is multi-tenant, right? The user might create a VM on AWS that might be in a different VPC from the other one. And then some, let's say, cluster information. All this is nice, and this create cluster API can be called from CORK. Now the question is, can we make SDDC stateless? How do we do that, right? So let's see one approach. So let's say I remove the database, and then move the credentials object. Let's say that's a table in RDBMS. Move to the CORK's database, and then I can add. I can add those credentials to the API. Notice that the API there is a third parameter called credentials. So this is a simple way to do this. Now SDDC is stateless, and I can. Now we have slightly changed how the API works. And with this, we can start SDDC, restart it, kill it any number of times. So we have the benefit of, let's see, oh, there is one more. So we have the benefit of scaling SDDC. We'll talk about that as well. Any comments so far? Right? Looks simple enough. Yes. Yeah, so we moved credentials to the CORK's database, database that only Cork is talking to.
But SDDC by itself, whatever you showed in the slide, is stateless because the data is in data.
Yeah, it is. So sure. Yeah. So yeah, so that is the key concept I'll get to. So it's about ownership of the state. Sure, of course, you store the state in a database. Service itself is compute part of it. The data part of it is somewhere else. But who owns the state? In this case, if we define it like that, SDDC, this part, that process is the one that owns the state. It knows the schema. It knows how to update credentials, delete, and so on, right? So that's the key concept here. And before we get to the ownership part of it, I wanted to show one more thing. So SDDC actually uses Docker machine. Anyone know Docker machine? I think most of you know. Yeah. So Docker machine actually allows you to spin up VMs on any backend, let's say AWS, vCenter, Azure, and so on. And it gives a very nice interface. So we were using that as a tool or kind of like a driver to take care of like deploying VMs on different backends. All that is nice, but Docker machine actually stores some stuff in this folder, right? .docker/machine. And we're stuck with it, right? We have decided to use that tool, and it has some state that's there. You have to maintain it. So what do we do, right? So what we are going to do is to, of course, we pass the same credentials and all of that, but SDDC is going to return some state back to Cork so that it can store that in the database of Cork. So all this magic, again, is to make sure that we can actually keep the state ownership in Cork and keep SDDC as stateless. Are you guys with me? And it'll become apparent why we did that when we try to scale and update and on failures and all of that. All right, so this is the key concept number 2, right? Who owns the state? And we want to make sure that a particular service owns the state, meaning that it's the only one which can update, read, delete the state in database. Everyone else or every service, every other service should only talk to it through well-defined API. Right? So that's the main concept. All right, so all this work to make sure that we can scale SDDC, and also if it dies, we can restart it without much problem. Right? So scaling we can do. We can have multiple copies and create clusters in parallel and so on. Right? Also, I have simplified a little bit. There are a few more gotchas. Right. All right, what happens if SDDC dies? Right? So we did all this, nice, it's stateless. If we restart it, will it be okay? Maybe. Maybe not? Why? Before I show, yeah. Right. Yeah, so that is one thing. Yeah, so I think the API call you make will kind of, let's say you made a call to create a cluster and it'll stop in the middle, but that's okay. The state is in Cork, so when you restart SDDC, it's actually going to get that state back. So I'll show that here. So the important part is that, so we stored this Docker machine state in the Cork's database, right? So SDDC dies and restarts, but then it's going to ask for, hey, what is my Docker machine state? Because that has to be maintained. We have chosen a tool that is stateful. And this happens quite a bit, right? You can design your own app to be stateless and with nice schema and separation of service boundaries, all of that. But you choose something that stores something somewhere on file system or maybe S3 or somewhere else, or it keeps some cache and that needs to be warm, and all that has to be repopulated, right? Reinitialized. So that is what this is doing. All right. So the third main point is how do we maintain state on failures, right? And I showed only what happens if SDDC dies, but there are other services, and we need to think about what happens if other things around it die as well, including Cork or database. So if failures happen, define a well-defined, first create a well-defined API so that you can get the state that you need from the owner, whoever it is, right? And reinitialize to consistent state. Okay. Right. Let me see how am I doing in time. All right. All right. Any comments so far? Okay. So we talk about the database, right? So when oh, go ahead. Yeah. Right. Right. Yes. Yeah. Yes. Yeah. So core can also be. Yeah. So core can also be scaled. I mean, the core can have multiple copies. The only problem is that you need to have now a distributed synchronization between those instances. Right. So that depends on your application. So we went with the philosophy that state should be in one service. Only one service should own the state as much as possible. But we kind of broke it. We kind of like didn't do for some other services. But you want to keep like most of your state in one service. And if you want to scale that service, you'll have to do synchronization across all the copies, right? And of course, if you are using data like a non-RDBMS, then you have to figure out like how you do the distributed transactions as well. Yeah, I mean, we moved it from one service to another one, but at least now we have one service where the state is owned rather than two of them. The application as a whole has state. There's no way around it, guys. No matter which application you're writing, anything you pick, right? Because stateless apps are essentially useless, right? They don't do anything. So you have state, if I'm talking about the end-to-end application, so you have to handle it. So there are some patterns we are using here so that we kind of centralize state in one service. Of course, you still have to scale that and figure out how you do the distributed synchronization and so on. But we are simplifying it a little bit. At least the SDDC restart is much simpler. SDDC upgrade is much simpler. Cork, maybe not. But you have to do that at some point, right? Yeah, I mean, that's always there, right? Earlier it was there for both the services. Now we moved it to one, so that you can design Cork in such a way that it's easier to restart. Like we can actually kill Cork and restart it, and it will get data from database, because the database we use is an RDBMS, MySQL, and it is highly available. We'll use a master slave. So those are the tricks you apply, right? You separate the compute and data and so on. Yeah.
Then you let your app be an app, and you let a state management service.
Yeah, exactly. Yeah. So in fact, I mean, we initially called it Cork, but I like to call it as a state manager. It's the one that maintains state and moves things from how VM started to deploy, that kind of state transitions. Right? Yeah. Yeah. Welcome to microservices. So sorry. Yeah. Yeah, so you can use, so I think, I mean, microservices, as you guys know, right? And we are breaking these into like 10 parts. One monolith, it was a function call or like a SQL query. Now it's like you have to make a REST API call. That's going to be there. But you can use cache, and like Nilima said, and also you can warm up the cache like when you're starting up. You can do a few tricks there. All right. Okay, so we talked about this. So the database, again, I want to make sure that I'm clear. I don't mean just the relational database, NoSQL or something, a key value store or a configuration management like the etcd and so on. And you have to choose the right one for the right use case, right? So we used console for our swarm state. We used influx for our time series data. And for all our relational data, like cluster has pools, user has clusters, those kind of relations we stored in the RDBMS, MySQL. And we made MySQL highly available with a master slave. And finally, database can go down as well, no matter how well you architect and make it highly available, all of that. So you want to make sure that your services can degrade gracefully, maybe like just read only, or just return with something sane. Right? All right, so how to update the services? So this is the interesting part, and Rian again will go into some of the theory of like how you do it right, and it's pretty complicated, right? So I see like from orchestrators like Kubernetes and Mesos, there is this rolling update features, and they all talk about very simple, nice structure of, hey, start the new image, let's say container image, and then kill the old one, redirect your request, everything is fine, right? So something like this, right? So let's say I go to V2 and kill the old ones, start the new ones, more of them, and then somehow magically everything works, right? Unfortunately, it doesn't work like that, right? I mean, we have state, and maybe for SDDC, if we thought carefully, I think we can make that work. But the challenge is, how do you upgrade the state, right? So I want to, again, think about upgrading the whole app or parts of app where I'm moving to a new schema or a new, like, whatever, time series, like I added a new column for my time series data. Then I want to make sure that I get all the services know about that and do the right upgrade. Right? So in-place update, it's a little complicated. We'll go through like step by step, right? So first I stop Cork and SDDC, let's say. Upgrade the database. We run a script that will move all the schemas from the old ones to the new ones. And there is a complication there. We'll get to that. And then restart Cork and SDDC with V2. And get state just as usual for SDDC. And now we are in version 2. All good? Do you guys see any problems? Yes. Why do we have to do that?
Yeah, so I'm thinking we need to get the new green start and get the new green, do the canary release, and partially migration.
Okay.
And also partially we consider new update procedure.
Awesome. Yeah, that's my next slide, actually. So the problem here is downtime. Though it might be cleaner to do this, for container management system, it is probably okay to do this because the containers are running anyway on all the hosts. Just the management server is getting upgraded. And this is right now, like for containers, actually, we have chosen this path, and it upgrades very quickly. In fact, Nilima, like one of our team members, she was at VMware as well. She wrote most of that code. But this has downtime, right? So if we want to do blue-green, like you were referring to, so what that means is that you would have copies of the same whole app, or maybe even some of the services if you can make that work. And the important part is that first one, the database has to be, or the services have to be set to read-only mode, right? So that you're not getting new updates. Let's say you're not able to create new containers and so on. And copy the database, upgrade it, start the new one, and then switch. Right? Maybe for a short period of time, you are running on both sides while the second one is up. Again, there are some complications, and we haven't talked about how to upgrade the database yet. Right? That's completely up to the application. And if you want to do partial upgrades of, let's say, only Cork, but not SDDC, then we have to worry about like the version differences and how do we maintain the previous version API and so on. Right? And Lian again has more details, yeah, maybe much more like fine-grained, like theoretical framework for that. So to do that, we also have a service called Workflow Manager, which I didn't show earlier, but that actually kind of is like a proxy that can do this. Now, quiz question. How do we upgrade WFM? All right. Okay. With that, okay. So that's all I have actually. I think Rian and Madhuri will talk more about like more of the deployment and upgrade part of it. So just to summarize, so every application has state, nearly every app, right? Because stateless apps, I mean, however, like we like them, but in reality, everything has state, right? So there are different types of state. We talked about deployment state, configuration state, which you should use an orchestrator to manage, and service state. Again, there is no help. I mean, it's you as a developer or you as the application owner has to figure out how to handle the state. And we have a little bit of framework around that, like from the distributed systems theory and practice and all of that. And no matter what people say, it's not easy. Right? There are lots of complications with failures. And if you want to do partial upgrades and if it fails, what should you do? How do you roll back? And how do you upgrade the upgrade service itself? So there is complications like that. So I have shipped version 1 upgrade, right? But that needs to be used to upgrade to the newer version. That code has to upgrade to the newer version. So we talked about ownership of the state. So that will give you a framework of like which service owns the state, where should you keep it, and maybe that's the only one talking to your persistent database, either NoSQL or RDBMS. And how do you pass the state through APIs? That's probably slightly easier once you figure out ownership. And how do you handle failures and updates? Hopefully, this has given some framework as to how to think about it. This is more from experience than theory. There's a lot of theory around this, and a lot of, I think, in like web scale companies, there is a lot more expertise around this as well. And I'm sure Rian will also talk about that. Okay?
All right.
That's all I have. Thank you.
Please put your hands together. Thank you so much. I just had one quick question to get the question started because we have a few minutes for questions as well. One of the popular theories that is starting to emerge is, I'm sure you've heard of the buzzword already. It's called serverless.
Serverless.
Yes. And so the concept there seems to be that people that are deploying applications have to care less about all of the details of this, either state management or upgrades, and let the people that understand how to do that, let them manage that part of it, and just have APIs to pretty much do what you have to do, or have programmatic ways of doing it. What are your thoughts on how state management kind of in that world, which is sort of piggybacking on the microservices revolution that's happening? What are your thoughts on how that affects the the state management?
Yeah, I mean that's a very good question. And serverless, it's clearly gaining a lot of hype. I'm learning as well. And so my thoughts are that it's not general purpose, first of all, right? So definitely you can take a function and make it, function itself can be stateless, but it has to do something. There is state anyway, no matter how you look at it, right? Maybe most of your functions will not have state, but eventually you have to, let's say your IoT devices are sending data to you, you have to put it somewhere. There needs to be a schema for it, whether it is you choose like a more flexible schema or like a relational kind of schema, you still have to do that. So all of that still remains. Maybe the patterns make it simpler to upgrade, but still again, now I have, instead of 2 services, I have 20 functions or 200 functions, right? And I want to upgrade one of them. Who knows how to do that, right? It's going to be complicated. But for some use cases, I think IoT, many people see that as a good way to solve that problem. Like how you get data from all your devices and put it into like maybe a time series database and then analyze it later. But state problem will remain. It's not going anywhere. Yeah.
Thanks. Do we have any other questions? Let me grab a microphone. All right, our next speaker has a question for our previous speaker.
Let me take the time. I think we have like 5 minutes. Yeah.
So are you running your database in container as well?
Yes. Yeah. So that's one thing I didn't touch upon, but so the database I showed that talks to, it's a MySQL database running in a container connected to a persistent volume. It has its own life cycle, and it again, if it dies, it comes back up. I mean, it of course keeps the data persistent and so on.
Basically, you're using a MySQL with container. You're using a master slave. If master failure, how can you fail over?
Yeah, so this comes up quite often, right? So Galera, like if you guys know, like it's a, go ahead.
Do we think about the map for master solution to make the map for ring, like OrangeDB, for map for master, like a
you can. Okay. Yeah, multi-master also. So if you're familiar with the Galera, that's a MySQL variant that provides this multi-master. You can do multiple writers and readers as well. you can set, yeah, some instances can be set as only like readers and from where you read from, and so on. So, and it takes care of the synchronization across all of them. So you can pick a solution like that and push the high availability of that database to that solution. Or you use something like Amazon's RDS. Yeah.
All right, we have time for one last question. I did see a couple of hands go up. Is there another question in the back? All right, looks like it's all answered.
All right.
Well, let's put our hands together.